In this lesson, we'll continue the journey to becoming human, and we'll focus on how natural selection modified ape anatomy over time. So here's our neighborhood on the tree of life, and we have learned that approximately 6 or 7 million years ago, one ancestral species of ape living in the forest branched into 2 lineages, one of which would lead to the chimps and bonobos, and the other to modern humans. Now, often what causes that kind of branching is a change in the environment somehow. So members of one species get fragmented into 2 separate environments. And so some 6 or 7 million years ago, as the climate changed, the forest began to recede. So the apes living in this forest now had 2 different kinds of outcomes. Some of the apes had to make a living in this new woodland grassland environment. And they would be the ancestors of modern humans. The apes that continued living in the forest conditions were the ancestors of the modern chimps. We can visualize this on this diagram. Here we have the split over 6 million years ago, leading to modern chimps, and then here's our lineage. And we've got some of our more famous ancestors: Ardipithecus, Australopithecus, Homo habilis, Homo erectus, Homo heidelbergensis, and Neanderthals and Denisovans, and then of course us, modern Homo sapiens. And so the genus Homo then begins roughly around 3 million years ago. And the distinction there is that Homo habilis, being the first in that group, had a larger brain than the previous Australopithecines. So in this lesson, we'll focus on natural selection and how it favored modifications of ape anatomy to better fit the woodland grassland habitat. All right, here's the skeleton of a chimp. And again, we're going to use the chimp as an approximation of what the common ancestral ape species looked like in the forest some 6-7 million years ago. We have a cranial volume of 400 cc's. Well, it was adequate for forest life. The foramen magnum is the opening in the skull where the spinal cord goes into the skull. It's towards the back of the skull, and that makes sense for a creature that has a horizontal posture. Pronounced brow ridge, we're going to be losing that, as well as the pronounced face here. Arms slightly longer than legs, that's an adaptation for tree living. So look how long the arms are compared to the legs. In fact, shorter legs is an advantage when you're climbing up trees. The long legs are nice adaptations for grasping onto branches and things. The vertebral column is bow-shaped. It doesn't have to support a lot of weight because the chimp has a horizontal posture. The pelvis is long and narrow. Here's the pelvis, and notice it's kind of facing forward, again because of the horizontal posture. And the hand bones are robust and curved. Well, these creatures are knuckle walkers, and of course they do a lot of holding on to branches. So look at the size of these hand bones. So they're very strong because they have to support the weight of the animal when it's doing the knuckle walking, and they're curved, and that's an adaptation for hanging on to branches. Check out a chimp's foot. Notice the big toe is opposable to the other, so this is a grasping foot. And they also have relatively flat feet. And these are adaptations for tree living. Now, by contrast, the human anatomy is going to show significant differences. First, of course, the cranial volume, 1,300 cc's, significantly larger than the chimp. The foramen magnum is on the bottom of the skull. In fact, here's a look at these 2 pictures over here. The chimp, the opening on the skull is towards the back. For the humans, the opening is underneath the skull. So the skull is balanced on top of the spinal cord, or the spinal column. There's no pronounced brow ridge, so our face gets flatter here. Our arms are 70% as long as our legs, and this would be an adaptation for walking, upright posture and walking. So long legs is an adaptation for more efficient locomotion in the bipedal posture, and our arms are shorter now than our legs. And then our vertebral column is S-shaped, and that supports the weight of the upper body onto the pelvis there. Now here again we see the pelvis here supporting the weight of the upper body, but also take a look at the thigh bones, the femurs. They're angled, and this permits for greater balance when we put one foot in front of the other. Notice the chimp, the thigh bones do not sort of angle inward. If anything, they angle outward a little bit. Now, chimps can walk upright on two, but just not as efficiently as we can. And take a look at the human foot. Here we have the skeleton of the human foot, and notice the big toe is aligned with the other digits. We also have more of an arch in the foot, and it will get more springy action, so we can push off when we're walking. Again, notice the skeleton of the chimp. The big foot, or the big toe, is not aligned, and it is opposable to the others. And this is a grasping foot, whereas the human foot is adapted for walking. So what about Lucy? Well, if Lucy's transitional, then we suspect that she's going to have features of apes and features of the future human group. And indeed, she really does. She's a nice example of a transitional species. And that transition, recall, is from forest life to grassland life. Now, Lucy lived around 3.2 million years ago in an environment different from the ancestors of our chimps, and supporting evidence includes fossils of Australopithecines like Lucy that have been found with animals adapted to woodland or grassland environments. In addition, Lucy's teeth show evidence of grinding hard and tough food, a diet change compared to chimps. So I just wanted to add here that there's evidence that Lucy was living in a different environment from the forest-living apes. Again, in the forest, where the current chimps live, food is dispersed, but it's close by. Whereas Lucy's kind had to make a living out on the woodlands and grasslands, where food is clustered but farther away. And so that would be a selection pressure for more efficient locomotion. And that's the bipedalism that we see in Lucy's skeleton. So we want to credit natural selection then for favoring changes to the ape anatomy to permit more efficient bipedal locomotion. Lucy was discovered in 1974. The term Australopithecus or Australopithecines means southern ape. And again, Lucy had skeletal features consistent with bipedal locomotion. She was about 3.5 feet tall. And take a look at that thigh bone. It was only 12 inches long. That's pretty short. And so initially scientists thought, well, maybe Lucy was a child. But then they looked at the lower jaw and they found evidence that the molars had already come in, and that's an indication of maturity. So they think Lucy was an adult, possibly 11 or 12 years old. Now, that sounds young, but for apes, they have faster maturation in apes, and so she was thought to be an adult, just 3.5 feet tall. Now, let's compare Lucy to the chimp skeleton. Again, here's the chimp. Notice the pelvis is kind of facing forward. Notice the thigh bones are sort of parallel here, and look at those grasping feet. Let's take a look at Lucy and the human skeleton. Notice the pelvis. So Lucy's in the middle here. The pelvis is tilted just like a modern human, and that would be an adaptation to support the weight of the upper body. Notice the thigh bones are angled inward like a modern human. Again, an adaptation for balance when putting one foot in front of the other. And look at the feet. The big toes are aligned with the other toes, just like in modern humans. And this is a foot that has been selected for walking, not grasping. Let's take a look at chimps and Lucy and humans walking around a little bit. All right, so notice then that okay, so we saw a great example then of how Lucy shows features both of the ancestral group, the ape group, and of the future group, the modern human group. Like apes, like a chimp, Lucy had the same kind of shape of the skull and the face, small brain, shoulder blades, again sort of suited for moving around in trees, long arms and hands with curved fingers, again adaptations for tree life. But like humans, her skull was on the top of the spine, like modern human, the tilted pelvis to support the upper body weight, the angled thigh bones for balance, and the arched foot with big toe aligned with other toes. A classic transitional species. In the next part of the lesson, we'll continue the story on the journey towards a modern human form.